Hello everyone, hope you're fine. So in mathematics, we have considering this topic called theorems or properties of a circle. Okay, so probably this is a circle. When we get this into our minds, circle theorem, and I think this is what comes in our minds, the circle. So probably what is a circle, if we are to put it that way? Well, ladies and gentlemen, a circle is not maybe what you're thinking is a round thing, but we define a circle as a set of points. These are points, set of points that are equidistant from a fixed point. So all the points are equal, that is equidistant. We are from discussing, learning, construction there. So that is a circle. Now, a circle has got properties that must be understood in order for you to answer any question given on this. Remember, this is very important. It's not an optional topic that this year to come. It was there last year. It won't come this year. It's not an option. It's a must. It comes in paper 1 as well as in paper 2. I'm sure you're aware of that. Okay, and if it comes in paper 2, it's there in the section A, not section B where you're supposed to pick. This one is a must. It is very, very simple in understanding, as long as you understand the properties. Well, before we go into details of the properties of this, there is need, first of all, to understand the properties of a triangle. Okay, because what will be forming basically inside here, there will be triangles. So if you don't know the triangles, that will be very, very hard actually to understand this topic. Well, I'm not going to go in details of the triangle. I've sent that video to guide you what I meant. Together with, that is under the Pythagoras theorem. Okay, so understand that topic perfectly well so that we can proceed with this. Well, under the circle properties, we are dealing first of all with the angles. Okay? Angles. The circle, total sum of angles in any given circle is 360 degrees. Point number 1. Your calculations under the circle should not exceed 360. Whatever you be given, if we are to add everything, it should give us 360 degrees. What I mean by that is, here is a circle, and then this is my center here, and then I divide this way. I say maybe this is 40 degrees. Okay, and then this here is 180 degrees, and then they ask you to find this. You put the x there. What should come in your mind there? So when I add all of them, they'll make a circle, and that will be equated to 260. Okay, that is the first point you need to know. Well, in terms of the triangle, in case I did not mention in that video, for a triangle, any given triangle, any type of a triangle, the sum of angles is 180 degrees. Any given triangle, any type of a triangle, the sum is 180 degrees. So this angle plus this angle plus this angle should give me 180 degrees. And then you've seen the types of triangles in that video, right? Well, where else 180 degrees? A straight angle. Straight angle always measures 180 degrees. With this in mind, then we are saying, if we are to divide a circle, a given circle, to divide a given circle to 2 equal parts, which we call, we divided, this is a semicircle, okay, so a semicircle, we will just have this part. That's a semicircle, okay? Like the way we have the protractor. So this angle, this is 180 degrees. So in short, we are saying a straight line is called a 180-degree angle. We are together with that, right? Well, now let's come back to this. So please understand that first video very well, and then all this will be much easier. Well, so with the circle, first of all, let's look at parts of a circle. Parts of a circle. The first one, a circle has a center. Okay? Remember how I defined the meaning of the word circle. So a circle has a center. This is the center. It will normally be represented by O, isn't it? Well, when I've got this shape, which is a rectangle, if I say from this end A, B, C, D, if we say from A to B is 10 centimeters, AC is 5 centimeters. When for instance, we ask to calculate for this weight, for perimeter, we say it's summation of sides, right? We sum all the sides, that is the perimeter. So we say, since this is 10, this will also be 10 centimeters, this will also be 5 centimeters, then we can add everything. And that will give us 10 plus 10, 20, plus this 30, okay? So that our perimeter there will be 30. We come to this. A circle has got a perimeter as well. We can find the perimeter of the circle. So now the thing is, the perimeter for the circle, we call it circumference. So circumference. So these are some of the terms which we'll be using, and the same terms will be used for the preparation of the exam. Okay? Under this. So circumference, when they say circumference, they are looking at it, the perimeter of the circle, the entire circle. That is the circumference. So this is what we call the circumference. We are together with that term? Well. Center here, then let me try to draw a line from the center, touching the what? The circumference. I've started using this width now. Say, okay, the line, let me do it in this way. It can be at any angle, provided we are saying this line is from the circumference, right? This line is from the circumference. So this line from the center to the circumference has a name, which is called the radius. It's called the radius. So radius is any line from the center to the circumference. Please, the basics are important. Can we say this is radius from a definition? No. Center to circumference, that is radius. If we now extend this up to that, then this one will be called radius. Singular, that is singular, but plural we say radii, not radiuses, but radii. Okay, so I've got this one again, radius, another radius. The region between two radii is what is called sector. That is sector. Did you see a question? The one I solved for 2019, grade 12, paper 1, there was a sector there, isn't it? So this is called the sector. There. So now, in this case now, we've got two sectors. There's this one, the smaller one, and the big one, right? So this smaller one, we call it the minor sector. Then this one is major sector. We move on from there. We want to extend this same radius so that it goes up to the other end of the circumference. So this is the radius here. After that, now I want to extend the same. After that. So for the first one, I also have the second one here. They formed a straight line, making a 180 degree and dividing the circle into two equal parts. Now, what is the name given to this entire line? That is what we call the diameter. Write it here. The diameter. So the diameter is from one end of the circumference to the other end of the circumference, and it should always pass through the what? The center. That is the diameter. There is a relationship, as you can see, which is there between the radius and the diameter. If I had to say the radius of the circle is 7 centimeters, what would be its diameter? So 2 radii makes a diameter, and that will be 14 centimeters. Take note of that relationship always. So if the radius is 3 centimeters, what will be the diameter? 6 centimeters, right? If the diameter is 3 centimeters, what will be the radius? 1.5, right? Good. So that is the relationship there. We move on. The next item. We now have another part. This time around is another line which is not passing through the center, but it's from one end of the circumference to the other end of the circumference. What is this line called? That line, ladies and gentlemen, is what is called the chord. It's not a chord. And that's why I no, it's chord. So this is the chord. These terms, please, I want you to understand them because these are the ones that will be used throughout the topic. So this is the chord. There is a region now which has been formed between this chord and the arc. This arc here. So this region here. Just like the way we have the sector is formed from the 2 radii, so the region or the area formed from the chord, that is what we call segment. So this is segment here. This is segment. Probably, ladies and gentlemen, these are some of the parts of the circle. These are some of the parts of the circle that you need to understand perfectly well and their relationships. We can move from here, I'm sure. So now, let's discuss the properties or the theorems of these circles. What you need to know here is when you are dealing with this kind of questions in the exam, you always need to have a pencil, okay? There's a reason for that when I'll look at some examination questions on that. Well, so the first property, probably before we look at this property, I think you've watched in the first video there, under the Pythagoras theorem. You've seen this, there's a triangle, and the name is given to that. There is also a triangle of this kind. This is what I said you have to concentrate much on. And then there is this one as well. And then we have this one as well. All these are important. All these are important here. Okay. There's also a triangle, equilateral scaling triangle, and the right angle triangle. And their properties. When you see this, meaning these two base angles are equal. When you see these three, meaning this angle are equal. When you see this, that means this angle is not equal to that, is not equal to that. If you've seen that, okay. So we'll be using these mathematical symbols also in there. So the first property is we have the center there. Okay, Okay, we have a center. Now let's try to draw a line passing through the center. You can draw it in that way. This way. Okay, passing through the center there. Okay, passing through the center. We have to give the name to that. That is diameter. Okay. So now, what again I want you to understand is when you have got a circle. I gave you an example of this to be radius. Huh? What you need to know is the definition, not where I'm drawing it from. This is also radius. This is also radius. This is so when you say diameter, it's not always that the diameter is like that. Even this is diameter, as long as it's meeting the conditions of passing through the center, and it has to be circumference or end to end. Okay, so we have this diameter here, and then using this diameter, the center here, or I can say diameter AB, and then from diameter AB, I want to form an angle. Let's say I want to form an angle which will be at this point. It should be at this point. We say maybe a form angle at this point. Okay, very well. Good. So there is an angle that has been formed, which is this angle here. From where? From the diameter. The properties say any angle formed out of the diameter at any point of the circumference, that angle is always 90 degrees. That angle is always 90 degrees. So this angle here is 90 degrees. So if I can form it even at this point here, it can be at this point here, as long as it is from the diameter, that angle will still remain a 90 degree. That is the first property. So when it comes to this topic, second theorem, be identifying triangles. That's why I asked you for the pencil. Okay, be identifying triangles and make sure that always in your mind, any triangle, any given triangle, the sum is 180 degrees, right? That's the first property. I'm sure we are okay. So if the question is given, as I'm teaching just like this, I'm also giving you examples and that thing. So if the question is in this way, I've got this is my center, okay, and then I have this, okay, that way. And then they ask me to find x. It's just like that. It's just like that. And then probably I'll say this point here, this is 30 degrees. Then they ask me to find the value of x. You don't have to say, no, only one point, only one angle is given. You have to know that, oh, this is the diameter here. So the diameter, automatically that is a 90 degree. So, since this and this and this are making a 180 degree, this is a triangle, therefore they will make 180 degree. So I'll add this plus this, subtract from that, I'll get that angle. Get that? Well, we can move on to the second theorem, I'm sure. We are together on that. The second theorem is, I've got a circle here, okay, got a circle. Then this circle, I have the center there, okay? And then I'm going to draw two radii, got this and this. Okay, so now look at the property. These are radii. The center is there. So the property is that using this radii and meeting maybe say A and B there, okay, then let me try to form angle outside, not in the minor sector, but in the major. Let me form using these two arms here. Let me form any angle at any point using this. So I'll form maybe, let me go up to that, maybe that way. You see that? Well, the property now says this angle which will be here and the one that has been formed here, there is a relationship. What relationship is there? This angle is twice the angle at the circumference. That is the relationship. So in short, we are saying if this angle is 40 degrees, then there's x here. Just know that this x is 20 degrees. That is the second theorem. That is the second theorem. Always, it's this inside, outside. You see that? Inside, outside. Now let's look at the opposite of this, which is theorem number 3. I've got this circle here. Okay? Then this circle has got this center, and then I have these two. Then I've got that and that as well. So now this time around, this and this. So this time around we said this is twice this. Okay. Now let's look at the other one here. The other one on the other side. Meaning this one which will be here will also be coupled with this one which will be here. Same relationship. So in short, we are saying if this is 60 degrees, then this angle here will be what? 30 degrees. Okay, I'm using simplified way of explaining that than the original kind of language in here so that you are able to understand. So you've seen the relationship there. It is this inside, outside. Outside, inside. That is the form that you should always know there. Okay? And remember that this plus this makes a circle, and the circle is said it is 360 degrees. Third, we can move on to the next property. Well, next property is that of the chord. We have the chord, so we have the circle here, and then the center. And then I've got these two radii. Okay? Again. Now I'll form the same way I did for the previous. I'll form one angle here using this. Sorry, the line is not straight. But when you are drawing, make sure that it is straight. Perhaps let me give us an example. When you're drawing such kind of things, I've experienced as well at some point whereby you want, okay, we'll talk about that when we reach the tangent. So I can have this point, this line, as well as the other line here. Okay? So, using this code AB, so I can join the code. Using this code AB, I've formed this angle. Angles from the same code, ladies and gentlemen, are equal. From the same code AB here, I can form another angle here. I can form another angle here. I can form another angle, just like that. So I can form another angle here. I can form another angle here. I can form another angle. You see that? So this angle, this angle, this angle, they'll all be the same. Angles formed from the same code are equal. So I can have, maybe this is 20 degrees, that means this will also be 20 degrees. If they ask me to find x here, I'll look at where is this angle coming from. I'll follow the lines that is from this code. This code has produced how many angles? It has produced this, it has produced this, it has produced this, it has produced. So meaning all of them will be 20, 20. That is another theorem. That is another property. Very important. So if you'll be able to identify this, remember those questions are just 1 mark, 2 marks. So the way we answer them is, first of all, you get your pencil, identify the properties, put them in pencil there. Don't focus on the questions. No. We don't answer questions under this in that way. First, put the properties there. What you can see, put them there. Then you see that angle ABC, this one. It will just be giving you answers, just like that. Okay, we can move from there. We look at another property. This property is in this form. Okay, got a center there. Now, this, I'm going to form a four-sided shape inside the triangle. I'll form four-sided shape inside the triangle. The four-sided shape inside the circle is what we call cyclic. Get my pronunciation there. Cyclic. What the? I'm sure something like that. Some cyclic quadrilateral, meaning it is within circle, four sides. Okay, four sides or four-sided shape inside the circle. That is a cyclic quadrilateral. So it can also be in that way. It's not always that it will be this way. The property is about the four-sided shape inside the circle. So it can also be in that way. It can be that way. Provided it is 4. Now what property are we trying to drive here? The properties opposite angles are always supplementary. Meaning, supplementary mathematically, that means add up to 180 degrees. So when I say supplementary, that is 180 degrees. Okay, add up to 180 degrees. Then we say complementary, that is 90 degrees. Well, so meaning opposite always add up to 180 degrees. So this angle, which can be x, and this angle can be y. X plus y will always give you what? 180 degrees. Together with this one and this one, A plus B will also give you what? 180 degrees. That's the property. That is the property there. So we can conclude to say any four-sided shape, being it a kite, rhombus, rectangle, any four-sided shape, the sum is 360 degrees for any four-sided shape. Okay? So this plus this is 180 degrees. This plus this is 180 degrees. Take note of that. So if you are given this and this and this, they ask you to find this. Then you say, oh, there are 4 of them, therefore I should equate it to 360 degrees. If you are given this, you are asked to find this. There are 2 here. Just know that you subtract from 180 degrees. Are we communicating? So with these, I'm giving you examples and other things. So probably these are some of the 5 theorems. I think there are about 8 of them, remaining 3 of them. So when I'm done with that, I'm giving you as well examples in here. So up to this, I'll be able to give you exercise, question, past paper question based on this. Okay, so with this, let me end here. Then the other part will just be finishing up and exam questions. Thank you for watching.